In the name of Allah, the most gracious, the most merciful, praise be to Allah, and peace and blessings be upon the messenger of Allah, our master Muhammad, and upon his family and companions altogether. Now, after finishing the general discussion in the first episode and talking about it in the second episode, we begin with you a new episode, a new challenge, and practical information that will benefit you in the job market about the fifth test is essentially a comprehensive evaluation that builds upon the findings and results of the first, second, third, and fourth test. This particular test, now referred to as the fifth test, is designed to thoroughly assess and ensure that there are absolutely no underlying issues or problems within the core components or any other critical areas. The purpose of conducting this test is to meticulously verify the integrity and functionality of the system, making sure that everything operates smoothly and efficiently without any unexpected complications or malfunctions. By doing so, we aim to guarantee that the system is robust, reliable, and ready for deployment in real-world scenarios. This test determines if the CT is for protection or metering. If the knee point voltage under 100 volts for a CT with a 1 ampere secondary current, it's a metering CT. If over 100 volts, it's a protection CT. For a CT with a 5 ampere secondary current, the knee point voltage is over 20 volts for protection and under 20 volts for metering. The magnetization curve is tested by applying AC voltage to the CT's secondary side with the primary open. We increase the secondary voltage from low to high, measuring current with an ammeter. If a 10% voltage increase results in a 50% excitation current increase, the prior voltage is the knee point voltage. For the metering CT, it's under 20 volts. The magnetization curve is tested by applying AC voltage to the CT's secondary side with the primary open. Slowly raise the secondary voltage, measuring the current with an ammeter. This is the excitation current. A 10% voltage rise causing a 50% excitation current increase marks the knee point voltage. Take readings around the knee point, then reduce secondary voltage to 0 to demagnetize the core and remove residual flux. The current generated by applying voltage to the secondary is called the excitation current. If a 10% increase in the voltage applied to the secondary corresponds to a 50% increase in the excitation current, then the voltage before this increase is the knee point voltage. To clearly draw the magnetization curve, we need to take several readings before and after the knee point, and then we start to gradually decrease the applied voltage on the secondary until we reach 0 to ensure the demagnetization limits of the core and to eliminate any residual flux inside it. To determine if the CT core is suitable for its ratings, the CPC can assess the core's performance. To clearly draw the magnetization curve, we need to take several readings before and after the knee point, and then start to gradually decrease the applied voltage on the secondary until we reach 0 to ensure the demagnetization limits of the core and to eliminate any residual flux inside it. CPC checks CT core performance for ratings, reports per IEC, IE if suitable. In the case of achieving the required performance, the CPC can report the core's performance in accordance with IEC or IEEE ANSI standards. After the assessment, the CT core's performance is confirmed to be suitable for the CPC, and link to the assessment is created based on the report's results. The CPC demagnetizes the CT core and generates a test report. Compare the measured knee point with the calculated one to ensure accuracy. You can compare the measured knee point value with the knee point value calculated through the approximate method to ensure the accuracy of the test. The sixth test is the loop resistance test, and this test is conducted before the CT secondary injection test to ensure that the entire loop is correct and there are no open circuits. We perform the loop resistance test by opening the 2 terminal blocks at both ends of the secondary side of the CT. We measure the resistance from the CT side and then measure the resistance from the burden side. We keep one terminal block closed and open the other. Then we place the testing device between the open terminal block ends. This device measures the total resistance between the open terminal block ends, which includes the CT and burden resistances. The total loop resistance is the sum of CT side and burden side resistances. Measured earlier, as they are in series, loop resistance equals CT resistance plus load resistance plus wiring resistance. The difference in measuring loop resistance versus burden is the current type, AC for burden, DC for loop resistance. Loop resistance is typically tested for CTs and VTs, but often skipped for VTs if VT secondary injection suffices. Test for a single earthing point for each CT loop to prevent circulating current. When measuring the burden, AC current is injected, whereas DC current is used for loop resistance. Loop resistance is tested for CTs, skipped for VTs if VT secondary injection suffices. Ensure one earthing point per CT loop to avoid circulating current. Connect CTs secondary to ground. Buzzing means closed grounding. If buzzing persists after opening terminal, another ground exists. And do not forget to test the single earthing point of the CT so that there must be one earthing point for each CT loop. Otherwise, the current will be divided and there will be what is called circulating current between the 2 earthing points. To ensure there is a single grounding point for the CT, we connect the CT's secondary side to the ground using a multimeter. If the grounding point is closed, there should be a buzzing sound. If we open the terminal block, this buzzing sound should go away. However, if we open the terminal block connected to the ground and the buzzing sound remains, it means there is another grounding point that needs to be located. The single earth point is usually located at the nearest point to the CT, like in the switch gear or in the LCC. A grounding point is not placed in the protection panel unless there are multiple CTs for just one protection, like in busbar protection, where the grounding point is placed close to the relay that connects all the CTs in parallel. The revival of a nation, indeed,